Thanks for being here, guys. This is the 35th Hawaii iOS Developer Meetup. The quote of the week is, "Technology is nothing. What's important is that you have faith in people, that they're basically good and smart. And if you give them tools, they'll do wonderful things with them." It's a Steve Jobs quote. So upcoming meetups on the 24th, O'Neill is going to be covering instruments. On August 31st, I'm going to be covering image caching, best practices. And then on September 7th, O'Neill is going to be using Swifty StoreKit to show us how to use that. Pro tip for this week is with Xcode 9 Beta 4. I noticed that when I imported images, that it does not automatically add membership. So I have to go in, and that is just such a pain, but it's good to know that it never works to just do that. So I'll just a heads up on that one. Next, housekeeping. So this is the Hawaii iOS Developer Meetup. We have a meetup page. You can go there and comment, join. If you're interested in becoming a member of HICapacity, they're going to be moving in here pretty soon. You go to HICapacity.org. And finally, for housekeeping, there's a bathroom on the left of the iLab right over here. Free tools that I want to share today are spectacleapp.com for keyboard shortcuts that resize the windows. It's pretty good. And also, we're using Screen Hero right now for cross-platform screen sharing to show your mouse and your keyboard. It's great for pair programming. And if you're interested in getting an invite, just give me your email. Okay, so tonight's agenda is we do introductions, and then I prepared just basically a talk on the ARKit by example. Okay, look at this screen. So we're just going to be going through this. I've done all 4 of these articles. There's one issue here with plane detection, is the updating of the plane detection. I can get one plane, but actually augmenting that plane as it gets more information, I just didn't get into it. So we can talk about that a bit later. I'm going to go back to my notes. All right, so that's prepared. And so before we get into that, how about let's do introductions. So would anyone like to go first? All right, Jay.
Okay, I'm Jay. I've been a developer for about 3-4 years, actually about 6 years, working on a project called HICapacity. It's becoming closer to beta. I just got to fix a little bugs here and there. So I've been working remotely with my partner, Syndicate Builds, for him to build it from time to time. Nice. So getting closer. Been working on this project for almost 3.5 years.
Just a quick question, Che. So you're working remotely with your partner. Are you using Screen Hero, or are you using like Google Hangout? Or?
No. Basically, we call on the phone. We had issues, so I did call, and I actually upload my build through WeTransfer.
Oh, okay.
And then he builds it. I showed him how to build and everything.
Okay.
So
nice.
So
cool. Just curious.
So that's how.
Right on.
We're gonna do it tomorrow morning.
Okay. Does anyone else want to go next?
I'm Tyler. I'm just learning Swift as a hobby right now.
Okay, thanks for being here, Tyler. Leo, you want to go next?
Yeah, I'll go next. My name is Leo. I've been doing iOS development for, I don't know, about 1 or 2 years. I was working in Tokyo. Now I'm back in Hawaii. I'm trying to look for maybe a project or a job if something exists in Hawaii. I don't know. I've been working on kind of like a Japanese-English bilingual puzzle game for the past couple months, and I uploaded it to the App Store yesterday, but there's a few more problems that need to work out, and hopefully I'll get it on the store by the end of next week, hopefully.
Nice.
Yeah.
Are you using full Japanese words or is characters? Or?
So what the game is like a puzzle game with tiles, and it's kind of two-sided. One is you'll have, for example, puzzle questions in English, and you answer with Japanese tiles. Another side is Japanese questions, and you answer with English. So, yeah, kind of like I wouldn't say it's an educational game, but it has that element to it. Yeah.
Cool. Thanks for being here, Leo.
Yeah.
Adam?
I'm Adam. I'm an iOS developer. I've been doing daily live streams, and I've been focusing on ARKit for the past week. I actually did walk through all these. These are great. It's a great tutorial.
Nice, yeah. I saw your talk today.
Oh, cool.
Yeah, that's cool.
It was way above my level,
but
I was just trying to like do my best to follow it. But when we get, I actually, I figured out that how to increase the size of the plane. So when
Oh,
we get to it, I
nice.
can help you out with it if you want to go through that.
Did you use it in Swift or Objective-C?
Swift.
Nice. Yeah. Okay. Perfect.
Yeah, at first it was like tweaking. It was like, what is? Oh, it didn't even like occur to me for like a day that, oh yeah, this is Objective-C.
Yeah, yeah.
You can kind of tell already.
Saw those brackets.
Yeah.
Yeah, Objective-C.
Yeah,
Yeah, sometimes Objective-C code can be a little hard to read.
yeah. I'll go last. My name is David from Manoa. I'm currently working on a transaction app. I'll be able to show you guys. I have iOS 11 installed so I can do the screen recording, which is a fantastic feature. And so I coded up an app that uses Firebase for user logins, and then it can see where you are, and then it tracks where someone else is logged in at, and you can do a transaction between the two. So pretty stoked on that. Right now I'm really trying to debug this issue with geolocation notifications for region monitoring for entering and exiting. So Adam and I have been working on it for about an hour, and we're still just
We're gonna get it.
yeah, we're gonna get it, but we're still working on it. So that's that. So any questions before we dive into the tutorials for ARKit by example? Okay, you guys ready? Here we go. Okay, so I'm going to go over to I got to keep looking at my own screen for this one. Okay, so I'm heading over to the website. So I've opened them up in tabs, and I'm just going to start with the first one. So we'll start from the top. All this is doing is this guy is creating an AR cube in space. This is basically, this first part of the tutorial is just using the ARKit scene project that comes in Xcode, and all he did was he replaced the spaceship with a cube. So I'll just go over to the code. Please bear with me. The code is just really gnarly. Just because I just did it, you'll see. Oh shoot, this is the wrong project. All right, so ARKit by example, starting with 1. If you have any questions, just feel free to shout them out. We're kind of a small group today, so we can take it at whatever pace. Okay, so I'm going to start off with the view controller. What I did here is I just created a new project, and I'm just going to, it's pedantic, but just right here, augmented reality app. So I'll cancel this one out because I'm not going to start a new one, and we'll just start from the top. Okay, so what I did was when you first start up this project, there's some boilerplate code right here. It creates a new scene, and it brings in the ship asset that's right in here. So it's just 3D model. Just waiting for it to load. So what I did was I commented that out, and what I've done is I've actually added in the cube. So I've actually commented this out too. Let's see. I'm just going to go through this because this is really kind of just minor, but maybe it's good to talk about it. So I'll just clear this up. So what we're doing is we're just using the same thing, and we're just creating a scene. Then we are, get the syntax here. All we're doing is we're creating a box using SceneKit. We initialize it with a width of 0.1, height of 0.1, length of 0.1, and I'm really not sure what chamfer radius is. Do you know what that is?
It gives your object a radius. So if you increase it, it's going to become rounder.
Okay, rounded corners kind of thing.
Basically,
Oh,
chamfering
okay.
is basically rounded corners.
Okay. Am I saying it right, chamfer?
Yeah.
Okay. All right. So the next thing right here is we got our geometry right here with the SceneKit box. Next thing we're going to do is we're going to load up a SceneKit node with the geometry of the box we just created. And it just creates a node now. And then after we have our node, we want to position that node. And we're just going to place this. Correct me if I'm wrong, but whenever you start up your ARKit app, it's going to take the location that you are currently in with your phone, and that's going to be set at 0x, 0y, and 0z. So for this one, we updated this last variable in z with a negative 0.5 to put it distance-wise a little away from us. So I think it's half a meter, 0.5. So each of these is a meter, these numbers. And then after we do that, we just add that box node that we created to the root node, which is the scene, or I guess the root node within the SceneKit that's inside of the scene. And then once we have that scene, we just assign it to the scene view that is created for us in the boilerplate right here, scene view. So that just, I'm not even going to go through it because all it does is just shows a white cube in the middle.
I have a quick question.
Sure.
So the width, height, and length refer to units of meters.
Mm-hmm.
Do you know how accurate the, I guess, camera or visual recognition is at finding distance? for example, is it possible that I have an app that detects an object and tells me exactly its dimensions?
Yeah, it's very accurate. It, have you seen any of the ruler
That's what I was thinking. too.
ARKit things that are out there?
I haven't seen that.
Oh, okay, yeah. So it's like extraordinarily accurate. They have examples where they have a ruler, ARKit ruler app. You can press these 2 points, and it will do the Pythagorean theorem for you. Like it'll make the triangle out of these points, and then the camera, and it's accurate. People have actually used a real ruler to within like a centimeter.
Wow. So I could like put it over somebody, and I'd be like, oh, this guy's like 5'10".
Oh, yeah.
Huh.
And I just read an article that explains why. Because you can have the software to do it, which is VIO, visual odometry. But the thing is, there has to be you have to do massive amounts of hardware calibration. And Google actually done this before with Project Tango, but they abandoned it because it's a pain in the ass to calibrate each hardware family. It takes a long time. That article explains it. And just because, and there are other SDKs that are out there that have the software, but if you don't do the calibration, you don't get the accuracy. And Apple's has worked feverishly to, since they have total control of the hardware and the software, they've been able to work out that the calibration and the error detection and removing the error. It's really painful. So
one thing that I guess I'm a little unclear on is that right now, so I see it as anchor points, right?
Right.
So we're using the camera, and we're also using the odometry inside of the phone itself, right?
Yeah, the motion sensors.
But there currently isn't any depth sensing camera features, right? That doesn't exist. So it's going off of visual cues in the environment.
Oh, and I read about the depth cameras, like the Google Tango. There are two major issues with that. One, it uses infrared.
Oh, okay.
Okay, that means you can't do depth. You can't use the depth sensor outside for obvious reasons, because attenuation from light and everything. The other is it eats up a lot of power. So the only other device that has that is the Microsoft HoloLens, but the problem is price, $3,000.
Yeah, and that one's sending out like sensors all the time, right? Like a radar kind of thing, the HoloLens.
Yeah.
So this thing is calculating depth for you. That's why, like, sometimes you have to move it a little bit,
right?
And that helps it triangulate on different points.
So it's triangulation, right?
Triangulations.
Okay.
So there's many ways of doing it, but the depth camera only works like indoors, outdoors, not so well, and not to mention power consumption, big issue.
So I guess maybe my question, another question is maybe too basic, but so as far as I understand, there's a camera, so you have one point of reference, and it stores this point of reference, and by moving it slightly, it's going to keep this point of reference as well as use this point of reference to have depth.
Yeah.
Okay.
It's called an AR point cloud or something like that.
Yeah.
So it keeps updating that amount of points.
So if we had it on some sort of like tripod or something, it would not be able to function because there's absolutely no movement.
Not as well. Like, I think it still uses your camera, even the basic camera on like the earlier iPhones, does have some intelligence to understand depth.
Right.
And it uses that, but then it gets better as you move it around.
Yeah.
It finds more feature points for you.
Yeah.
That's the secret sauce. Like that ability to get the depth and, like you said, remember what the world looks like around you.
Right.
Yeah.
That's why ARKit's going to be a game changer.
Yeah, and they've been able to, and of course that requires a bit of hardware, software integration. Yeah, you have to be, it's specific for each device, turns out.
One thing I'm finding when I'm using ARKit for projects is that it's kind of a pain in the butt to like have to like start it and then like move around with it to get it oriented. Yeah. So have you guys had any thoughts about like, just someone picking up a phone and be like, oh, I want to check out ARKit, and then there's like
actually finding the planes.
Yeah.
Well, the Apple example that I did today with the AR example app, they do a nice thing where they give you visual cues. Like they actually tell you need to move more, and then they show you like this nice looking target region once it finds the plane.
Oh, okay.
And then it's like, oh, okay, I can put my
And
thing
what you
there.
do, take that
How
PS
Visual indicator.
So basically, what you could do is take that code and reuse it in your own projects.
Yeah.
Yeah.
They did the hard work for you, so don't reinvent the wheel.
Any other questions, anyone?
No,
Okay.
I'm sure there'll be more.
Yeah.
Yeah.
Keep them coming. Yeah, it's good for conversation.
Of course.
Okay, so I'm not going to show this part. All we're doing is we're replacing the spaceship with a white cube. So I'm going to keep going. So that takes care of part 1. So just making sure we got through all of this, drawing the cube. Okay, on to the next. I'm going to close this tab. On to 2. So for this one, we're doing plane detection and visualization. So I'm just going to scroll through this. Would it be helpful for you guys who haven't done this code? Adam and I have done it, but do you guys want to see this video? Would it be helpful, or?
I mean, if it's not too long.
Yeah, we can pause it whenever. So here we go. Shoot, I think the signal is kind of slower than what's going on over here. Might be taxing it. So basically, this is a debug mode right here. So it shows these feature points.
Yeah.
And you are able to see, the more feature points you can get, the more accurate the reading can be. Once it gets enough feature points, it can detect the plane, and then what it's doing is we're drawing out another, like a scene kit, like just plane. And what he's doing here, the reason it looks, I'll try to get it in a better.
So when you say a feature point,
Sure.
is this just like a distinct, unique point
Yes.
that it understands to be on the plane?
Yeah.
Okay.
So let me dive into that a bit deeper because
So
I think
for
he has.
example, let's say we had like a completely white table. It'd
Yeah,
be hard.
super hard, yeah.
Okay.
And I think in here he has some pictures too that what's a good one, what's a bad one. So for here, below is a screenshot from my phone looking at the arm of my sofa. As you can see, the fabric. Shoot, come on. I'll refresh this page so you can see it. Okay, so you can see feature points there because
Yeah.
it has all that, you know.
The texture.
Yeah, the texture there. Then he does a comparison to that with his fridge, which is reflective and very few feature points.
I see.
So that's just kind of the idea right there. So I'm going to dive back into the code and we'll look at this stuff. So, all right. So in order to show the feature points, all you need to do is just set up those debug options. So you just go for the scene view and just set debug options, show feature points, and then you get to see all that stuff as it comes along. So I'm going to keep moving on in from line 100 to 112. This is just view will appear, and this is just regular configuration. We're adding in plane detection for horizontal plane. I was wondering, Adam, if you wanted to talk about, I remember today in your video that you were talking about doing the test to see if the device could, like,
Sure.
yeah, if you could talk about that. 'Cause I
So
haven't-
some types of devices have the ability to do this world tracking session, which means that it, like you were talking about, it can remember and understand the entire world around you. Older phones and older iPads don't have that capability, and you have what's called the AR orientation tracking session configuration.
Okay.
And really, like from what I've learned, it's like the object just follows you around like a puppy. Like it doesn't stay in the real world like it's supposed to. So you can do, I think it's like AR session, like has world tracking or something like that.
Okay.
You can just do it if else check, and then if it has world tracking, you use this configuration. If it doesn't, either you bail and you're like, hey, you can't use my app, or you can use the crappier orientation session.
Follow me kind of thing.
Yeah.
So
Okay.
is that a hardware dependent thing, or
Yeah.
is that an
Yeah.
iOS version dependent thing?
Yeah, iOS before iOS 11, you don't have access to ARKit at all,
Okay.
so it's just hardware dependent.
Okay.
it's
As long as,
hardware.
okay.
And you can set, I haven't tried this, but you can actually set a flag in the App Store, so you can actually say, only show this app to people with more advanced hardwares, so that other people don't even see it, get upset by it. Yeah.
Okay, so we're moving through here. So we've got in our configuration now we have plane detection. Just moving on. Next thing we want to do is once it does realize that it can create a plane, we're talking about this code right here, then we're actually going to create the plane. So for this one, I didn't really follow the tutorial code. I just went and found some more code. So just basically set up a plane anchor, AR plane anchor, set it up as a scene kit plane initialized with the plane anchor X and Z, so it gives it that, like, you know, that plane. Then we set, same way that we did with the geometry for the cube, we just set it to the plane node. We position the plane node, and then we, what is this one?
It starts off perpendicular, so you rotate it down.
Oh, okay.
Yeah.
And
That's
that was
the-
what this one was, right? The rotation.
Yeah.
Okay. All right. Any questions? Keep moving on. I think now we're getting into actually tutorial 3 here.
So I think it's one good thing to point out is that this is a delegate method that this is getting called in. So renderer did add node for anchor. This gets called every time your scene kit finds a new anchor, which can be a feature point. So there's two types of
okay.
anchors. You can get a feature point, like something that it distinctly sees, or it can be a new plane. And this is only the first time that it sees it. And what's nice is, because it's paired up with scene kit, it adds the anchor, and at the same time, it adds the scene kit node for you at the same place. So that's why we're checking, is this plane anchor an AR plane anchor? And if it's not, we bail.
Oh,
And
okay.
if it is, it's like, okay, now we're working with a plane that's coming for the first time.
Is there a debug plane anchor, like visual, versus the regular focus or feature points? Do you know?
No. You have to do what you're doing.
Okay.
Yeah.
Okay. Any other questions, anyone? Okay, so we keep going. So now that we've created the plane node, I'm actually going to go back over to the tutorial just to make sure we have everything. So we've done the debug mode options. We're detecting plane geometry inside of this delegate method right here in the renderer. We render the plane, we flip it, like Adam said, and then we add it to the scene right here. So for here, this is the code that I didn't get, is the update of the plane. So how about let's loop back to that one, maybe toward the end. But so updating the plane, we're going to skip this for now. And yeah, so we're getting to the point where we can actually see a plane. I also want to, I went into this project thinking like, dang, that's pretty cool, ARKit, that you put this cool like grid and everything, but it's actually the guy who created this tutorial. He did his own, he made his own transparent PNG to do these overlays. So you got to add it to the scene kit
And the thing,
node.
thing is, if you can, basically, if you find something useful, incorporate it in your own projects.
Yeah.
Reinvent the wheel.
I'll probably be using this PNG for my plane detection. I like it. It looks
This
good.
picture is interesting because it doesn't look like the grid perfectly aligns with the table.
Mhm.
You find that most of the plane detection is kind of generally good, but not perfectly good.
Yeah, mine, I noticed like almost like 2 centimeters worth of just like offness. Yeah. Okay, so I'm going to keep going. So this is the rendering of more planes as it finds more. And then this is the part that I do not have right now, is the putting together of all the planes that it's detected to find a bigger plane surface. So we'll loop back around to that if there's time. It looks like there will be. So we're still on planes, showing how effective it is. And I guess that's the end of this one. Next one. Before we move on, does anyone have any questions? Okay, so we're going to be adding physics in the next one, I believe. Just go to the top of this tutorial. So adding geometry and physics fun. This is pretty straightforward. But first thing we want to do here is we're going to do hit testing. So again, I apologize. I jumped out of this tutorial and I just brought in some code that I had for another AR project. So I did use touch as began. I didn't use handle tap from as a UI tap gesture recognizer. So I'm just going to kind of quickly walk through this code. Is that once it detects a tap on the screen, it's going to find that tap point in the view, and then it is going to translate that tap point into the 3D space that it is aware of with ARKit. So that code's right here, and it gets the AR hit result to see if you actually tapped a point that does have, I guess, a feature point. And then if it does find something at that feature point, then it's going to insert geometry. So what this is doing, big picture, is that this is when you tap the screen, it's going to create that cube in AR space. but it's just going to stay there because it has no physics on it. So here we go. So once we're talking about right here, this insert geometry right here, we have create a function right in here. And what this function does right here is it creates the node, and then it actually adds physics to it, and that's it. So we'll go through this code real quick. Insert geometry finds the hit result. It creates the cube like we did just before, assigns this cube geometry to the SceneKit node, and then in here it gets pretty interesting. So the great thing about SceneKit is that it has support for physics. So with the SceneKit node, you actually get a SceneKit node with physics baked into it. So the way that we get to that physics is we address the node itself, go into its physics body, and then we initialize it with this body type dynamic. Shape is nil. So body type dynamic means that this thing will actually, it's not just stuck there anymore. It's gonna just, it can move around. So next thing we do is, now that it can move around, we add some mass to it, and that'll make it drop down, right? Next thing we want to do here is, for this one, these category bit masks, I think this is a 15 bit long int that categorizes this specific node to figure out what it's going to collide with. So it's giving it, this is actually, I believe it's an enum right here in the background with Objective-C. So I just jumped out of it, did it in Swift. It's a little different, and I'm happy to post the code so you guys can use this later on. So I'm going to keep moving down. So after we created the collision bit mask, we're going to go over and we're going to position the node right now. We put in this insert Y offset because we just want to make sure when we tap it, we want to make sure that the cube is created just a little bit further away from us so we can see it drop. And then we put it into the world by positioning it right here with the offset right here. And then we do the same thing, just add the child node and then put in the add it. For this one, I think he's just creating an array of boxes so he can keep track of how many objects he created. So that's pretty much it. I'd say the first time I went through, I was dropping boxes and it was just falling through. The gotcha is you got to put physics on the plane as well. You got to make sure it can collide.
Also, you have to basically put on the plane as well as the objects as well.
Yep.
Otherwise, it won't respond.
Yep.
I have a brief question.
Sure, sure.
If you could go up real quick. There was a node.physicsBody rules. I noticed you have shape is nil. What does the shape reference? Because wouldn't that be like some sort of cube shape? Or?
I believe the shape is what we're creating here. So I think it's already in here. I might be wrong.
So what it is that SceneKit will, if it's a relatively obvious shape, SceneKit will just take the shape that you've given it. So it knows that it's a square or a sphere. If it's a more complicated shape, like if it's a 3D rendering of a person, then you pass in the shape there.
You'd have to make that custom shape.
It would be this one right here. This shape?
I think you actually have to pass in some kind of, forget exactly what it was, but when I was doing my reading, it said for all typical shapes, like spheres and whatnot, it can figure it out. But if it's a like crazy custom contoured shape, then you pass in some kind of shape data.
Okay.
If it's like if you're modeling a person and you wanted like two people to be able to like stand next to each other,
shake hands or something.
Exactly. Yeah.
I wonder if you use a ton of shapes, if having the app itself try to figure out what kind of shapes it is some sort of processor speed box there.
Probably. Yeah.
Okay.
If it doesn't explicitly set, it's just a lot easier to figure out.
And also, I think you can import models.
Yeah, I would like to get to that in a future meetup, is using the DAE models.
Exactly.
It's pretty. It actually turned out to be pretty easy.
Oh yeah.
Yeah.
Where are you getting your shapes? Sketchfab?
I did Sketchfab, but it's hard to find DAE models there.
Yeah.
So I also looked at TurboSquid.
Oh, found some on
I
there.
found some. Found a cool missile that worked out really well.
Oh, nice, nice. Cool, cool.
And of course, or whatever models and whatever modeler you use, you can always import it to DAE.
Right, right. So I'm just kind of putting this out there. As I've been thinking about getting 3D models, I have this idea for an app that I'm thinking like, you know, it'd be cool to be able to do 3D scanning with your phone. It's kind of where I'm at right now. So I'm thinking about the point cloud, being able to somehow render in real time what the phone is seeing, and kind of get like, I don't know if everyone's seen the Radiohead video where it's like this sonar thing. It's like these dots in 3D space. Thinking something like that would be really cool to look at. So if anyone wants a pair on that or collab, let me know. So any other questions before we move on? Okay, we're gonna keep going. So next thing we're doing, we just did, we added the physics. So we're scrolling down here. Stopping plane detection, I didn't do this, so I can't really comment on it. But that covers that part 3. Any questions? This next part was actually my favorite. I really enjoyed adding graphics to these cubes. So yeah, text, albedo, occlusion, or not occlusion, we'll get to it though. So basically what we're doing is we're gonna turn our white cube into these really nice looking, well lit 3D renderings. So scroll down. Scene lighting, I thought this was pretty interesting. I'm just gonna go over it really quickly. What you can do here is you can have your iPhone's camera get a sense of the light in the room, and then have that kind of light your 3D objects. So it's pretty awesome. I really enjoyed that. The code is in here as well. Just going down. There's different kinds of lights. You can set up lights inside of your scene as well. I didn't do that. So I did light estimation in this one as well. Yeah, pretty straightforward. Nothing that cool to really talk about in here, so I'm just going to keep going. Adam, you want to say anything, or was the lighting part too?
The only thing that, so with the lighting, you add a node just like any other node, just like a box or a sphere. You create a light, you create a scene kit light, you set a type, so it could be like a spotlight or an ambient light. You can do things like set the temperature and the brightness, like to match where you're at. And then you position that light, so like you want it a meter in front of you, you can like set it exactly where you want. And then you can actually change the rotation of it.
Oh,
so
okay.
it's like on a swivel, and you can have it pointed at your stuff. And that's all animatable.
Oh wow!
So you can have like a disco party ball and stuff.
Nice, nice. Just by a show of hands, who's used Unity? Okay, because the reason I'm bringing it up is that the lighting in here really maps very well to the Unity lights, like spotlight, all that kind of stuff.
You can use there's a Unity plugin that allows you to access all the features of HICapacity within Unity and on your engine as well.
Anyone interested in learning about that one with Unity, or I'm just sticking?
Yes.
Yeah.
Yes,
Okay.
I just
Good
did
note
it,
real
but
quick.
I just gotta finish registering.
Okay.
Still fine.
So in your experience, how I guess how good is the artificial lighting? If you put it within a certain, let's say you put it in a room, will it light up the walls in all planes, the ceiling included, or?
No, it just lights the virtual object.
Oh, it just lights the virtual object. Okay.
That screwed me up too. So like, see, check this out. This is one with the spotlight. So I put in a cube.
Yeah.
And the spotlight is up here right now. So you can see it's bright here,
Yep.
and then on your side.
Oh, it's dark.
And if we put some more cubes down here, the light doesn't even hit it, because it's like if it was physically there, coming down right here.
I see.
And then if we put some more, like, you can see that it's so wild when you're looking at your phone and you see this stuff. And you're like, whoa, it's not even
Where
there.
did it go?
Absolutely.
Yeah.
Okay. So we just finished this one out. All right, so here we're getting to actual adding images to our 3D rendered pieces, or scene nodes. It's just kind of a showcase. I'm not going to go into all of these because honestly, I'm not an expert on this stuff. Albedo is kind of the general look of things. The roughness is going to be, maybe this is a good time to actually bring it up in here. So we can just look at the different aspects in here. So we have albedo. Shoot, I wish I zoom in on that. But just, you know, that's the basic look of it. Then you have, a normal map, just kind of the texturing of it, and then the roughness. You can't really see it in this tiny little view. but that's it. One gotcha on this one, I'm noticing in Xcode 9 is, prior to using Xcode 9 when I was using 8.2 or 3 or whatever it was, is that I could just drag in PNGs directly into my file manager right here on the side. I'm finding though that I'm running into so many errors trying to render those images throughout my projects, and I found that the only way out of that was to pull them into this asset XC assets right here. When you do that, you pull them in here, and then as you refer to images like UI image.init named, remove the extension. You don't use the extension anymore on that one. So that's kind of a change in my process of doing things. I was just knocking my head against the wall trying to get a loading image working, and I couldn't. Finally did a bunch of reading into it, and this is the way that I'm going to go do things from now on.
From now on, you can just drag it in, the image into the, without putting UI image.
Oh,
Name, right?
I don't know. I didn't do that. What do you mean? Like when you do UI image
Right.
.init, you
Yeah.
can just drag it in?
Yeah, that's what it did. And then you don't, and it's this, if you type your name on your icon, it gives you that icon like a small thumbnail.
Oh yeah. I've seen those.
Yeah, it should autocomplete.
Okay.
Autocomplete, yeah.
Images, yeah.
Okay.
But make sure your naming is good though.
Yeah.
Okay, so I'm going to head back in. So that was those things. And then for this one, I pulled in some different code, so I'm going to just go back over. All it's doing is it's setting up each of those: albedo, roughness, metal, and normal map, all in this material. So maybe it's helpful to look at some code to figure out just how to set that. So we'll go back over to the view controller, and I'm looking for a material. Okay, so that's the plane. And I'm heading over to, okay, so shape node. All you do right here is you just grab the geometry inside of the shape node, and then you just get the first item inside of the materials that are returned back. And you set that first item with the all these albedo, roughness, metal, normal. It's pretty much just do this way, the same way every time you have an object, and it works. So took care of explaining that part. Anybody have any comments or questions or anything you want to add to it?
Just real quickly,
Sure.
albedo was like the main color of it, and the
Yeah.
metal refers to like the reflective.
Let's look into this one because they have it written up in here. So metalness, so it's the kind of the shininess,
Okay.
and then the roughness is going to be that like, yeah, that odd looking one that I showed in here.
So this is, as a developer, you won't know what to do. Like you have to have your 3D artist prepared for it. Like it's basically a way of preparing 3D art.
Okay.
So they'll give you the points. They'll give you like what the shape should be, and then they'll give you these, just basically these textures, and you apply them, and then the light rendering looks great. It's not something you can really figure out unless you're an expert in this stuff.
Yeah, I have no idea of anything to do with 3D rendering, but I wonder, is this like a standard
Yeah,
outside of even iOS development?
it is. Yeah.
Yeah.
So inside of like Unity, you have materials that you assign to an object, and you
Okay.
get to tweak them. Albedo is
So
a word too.
even if, let's say, I were to do something in Android, I'd probably be using the same, the
Yeah.
albedo metal. And
Yeah, for 3D rendering.
The key is physically PBR, physically based rendering.
Oh,
That's what I'm not sure if Android calls it that exactly.
no,
but-
same thing. All 3D is physically based rendering. It's a standard.
PBR.
Yeah.
Okay. All right, so I'm going to keep moving here. So we're about a little over halfway time. For this one, this is again lighting. I just kind of didn't even get into this, but I understand that you can feed in a picture of the scene that you will be rendering your objects into, and then SceneKit or ARKit will be able to light your environment based on the picture that it pulls in. Is that kind of it?
I understand. Yeah,
Okay,
I
good
didn't
to
know how
hear.
to do it, but that's,
Okay, so we're gonna keep going on this one. Okay, I think that is it. So we covered physics and everything. So it's built on my phone right now. Would you guys like to go into updating the planes next? Would it be helpful? Or, I mean, or we can just talk, or we can call it. Up to you guys. That's all I had prepared for tonight. So, up to you guys. Any preferences either way, guys?
Let's go. Let's figure out that plane.
All right. So we've got about 19 minutes. Let's get into this. So I'm going to go back to the first one, plane detection. I believe it's in here. Okay. So basically what we're doing is we're finding a plane and we're adding it to the world. So detecting, we've covered that one already, and we did the did add node. Then, like Adam was mentioning, is it looks for the point that it's looking, it is found, and sees if that is a plane anchor versus just a feature point. When it does find a plane anchor, it creates a plane node, and it just puts it onto the world, and then adds it as a child node to the scene. So now that we have that, the next step is that, okay, I think this is the one we just covered, right? Okay, updating the plane. There we go. So we'll start right here, and I'm happy if anyone wants to pair too. If you want to hop on this computer, it's fine. So let's just go through here. So if you run the above code as you walk around, you'll see new planes rendering in the virtual world. However, the planes do not grow properly as you move around. ARKit is constantly analyzing the scene, and as it finds that a plane is bigger or smaller than it thought, it updates the plane's extent values. So we also need to update the plane scene kit is already rendering. So we're not doing that. We're just adding new planes wherever we find them. So here we go. Did update node is going to be a delegate method within ARKit. So I believe I've added it to my code already. I'm just going to copy this. I can just find it in my code real quick. Did update node, going back to Xcode, headed over to the view controller, collapse this. I'm just going to do a search real quick. Okay, it's not in there. So what I'm going to do is I'm going to head back over to Firefox, and I'm just going to copy this. Actually, I'm just going to copy this right here. So we're looking for did update node, and I'm going to rely on code completion on this one. So I'm looking for my renderer. Okay. Nope, that's not the one. Where's my other renderer? Okay, right here. So I'm just going to add it below for the update. Okay, I have it in here. Okay. So, anyone have any ideas of where to get started on this one? Did you end up creating a plain.swift file?
I did.
Oh, okay, okay.
Yeah.
So I did create it, but I was at a loss for where to go with it. I just did it in it.
Yeah, if you want, we can go to my GitHub. And
yeah, why don't we just do that?
We could talk about the basic. So the basic concept is that the very first time ARKit finds a plane, it calls the delegate method called did add node. So if we're searching around, usually we'll take like 5 seconds, and maybe it finds this table first. We'll get did add node with did add anchor with this geometry right here, and it might just have like a square, probably looks like 3 by 3 or something, and then you keep going around, and maybe it'll find the floor. So did add anchor with node will get called for the floor as well. And you keep going, and then it sees that, oh wait, this plane is a little bit bigger than I thought, and then did update node will get called. And at that point, it's already found 2 nodes, right? So it's found 2 anchors. So you need to be able to keep track of which anchor is which. You need to, like, it's the one on the table or it's the one on the floor. And then what you want to do is you want to say, because it's updating a node, and each one has a unique identifier, you want to pull that one out, you want to store it, pull it out, say, okay, we're going to update the size of this anchor.
Right.
And then re-render that cool graphic you had.
Right, right.
So yeah, my Atom on the Run is my probably just go to repos then, yeah. Yeah, study iOS with Atom Live. And then planes and hit test, the third one down. And then overlay plane is what I called it. Yeah, you could just so what we're doing here, so this is just a way to model a node. So this is a subclass of an SCN node that we've been making. And what it's doing is you initialize a plane with an anchor point, okay? And when you want to set it up, this is when did add got called. So you set it up by your geometry is using, just like you did with the extent x and the extent z.
Right.
Set the materials. I have a picture for that. Then you create a node using that geometry, and you position it, again using this position point, and you rotate it down, and then you add the child node to
the root node.
because we are a node. So we're adding a child node. We're adding this plane node to us. And then when it gets, so that's when you first get added. Then when update gets called, you update the geometry of the plane to reflect the new geometry that's getting passed in the anchor.
Okay.
So, and then, so that's how this model gets called.
Oh,
And
okay.
we go back a level to the view controller, and we go to view controller. Then let's scroll down to the delegate methods. Okay, so did add node, we're saying just like you did, give me the plane anchor as a plane anchor, otherwise it's fail. And then our plane node, we call the initializer that we just had before, anchor with plane anchor. And we have an array of planes.
Okay.
We add that to the array so we can keep track of all the planes that we have. And then we add that. We're adding this node to this node. So that puts it on the screen. Now, when it gets called again, and basically, okay, we found that it's an extra 3 feet long, we're going to go to our array of planes, and we're going to find the first one where the anchor identifier
Oh,
equals
nice.
the anchor identifier. That way we can pull it out of the array. Then all we have to do is cast it as an AR plane anchor, and then update our overlay plane using that update method that expands the geometry of it.
Okay. Okay. All right.
Yeah, so that's how that works.
Do you guys want to just integrate this, or?
Yeah.
Yeah? Should we go for it? Okay. So, does anyone want to? I gotta plug in my computer real quick. 11%. What's the first thing you guys want to do? Maybe create the array of planes. Be helpful, right? Add it.
Well, we don't have an overlay plane class. Or did you call yours plane?
I just called it plane.
Okay, yeah, we'll
Swift.
just change that. Yep. I think this. Do you need a?
Yeah.
Yep. Probably one here.
I gotta plug it back there. Okay, so how about let's update maybe the plane class first, and then, or did you guys have a different idea of which one to do first?
I think, yeah, you should do the model first.
Okay.
That's the best.
Okay. You mind if I just copy your
No,
code?
no, please.
Okay. So overlay plane. Is there a copy? Just realized.
I think if you go raw, then you can just copy it.
Nice. I know that. Okay, so I copied this one. We're going to head back over to our project right here in plane. I'll just paste it below so I can do edits. All right, so we've got UI kit and AR kit. Copy these two. So is scene kit inside of UI kit? Is that why we don't need it for this scene node?
I think so.
Okay. All right, so let's go for here, overlay plane. Let's do the anchor and the plane geometry. Next, I'm going for the init. Anchor, init with anchor, plane anchor, self anchor, okay, and then setup as well. Shoot, I'm just going to grab it wholesale. All right, that's that. We do a build. All right, looks good. Okay. So I'm going to head back over to GitHub. Next, I'm going to go for the view controller code. And I'm going to go all the way down to the delegate methods. I'll just copy both of these right now and see what breaks. So we head back over to the view controller, and I'm going to go for the renderer. So did update, I'm just going to delete this did update. And so we have update at time. Okay, so that was just the light estimate update. And I'm going to paste these in. So we've got the renderer did update and renderer did add. I'm just going to make sure that I don't have this. Okay, so I have that there. Plain anchor. How do I want to do this? Okay, let's clear out all of this. Clean it up. Okay, so I want to do a comparison. So I want to do side by side. I'm going to collapse this one, or actually I want to get that out. I'm going to go side by side, just so I'm pressing Option, click, so I get it side by side of the same file. I'm going to collapse that browser, and I want to get this one that I've created, and I'm going to scroll down to what Adam has created here. Okay, so any feedback on this? Or wait, this is I'm looking for did add, so I should have two did adds. There we go. Okay. All right. The method signature looks the same. So next thing I want to do, plain anchor. I see all that. I'm just kind of just comparing them right now. Plain node, overlay plain. So this one I'm going to update it with what you have here. Shoot, I'm just going to copy it. Plain node planes.
I think yours is called plain, and mine is called overlay plain.
Build, and then I think we can get rid of this all the way to the add child node. You don't have physics. Your physics is taken care of inside of the plane.
I just didn't. I didn't do it as part of my example.
Oh, okay.
Yeah.
Let's see. So for plain node, I'm just going to take out this because we took care of the flip. I guess. I'm not sure. So we'll position it as well. Transform.
Yeah, the flipping actually happens in the model class.
Okay. I'll delete all that stuff. And the position too, right?
Yeah.
Okay. Then we add the physics, plain node. Yeah. Let's see if we can build right there. I'm racing against time. I see we've got 6 minutes. I just want to get this. Keeping going. Cannot convert plain to expected argument. Planes. Okay, so planes created. I'm going to command click to go to the definition up here. So it's a SCN plane. For this one, I want it to just be planes because that's the model class that we created on that one. I'm building. I'm going to go back to planes. And so I see this. So this is Adam's code. I'm just going to delete this now because we've copied everything. Now we only have one did add. And looking at it, we didn't have to do a bit mask on this one because I looked into the documentation, and actually if you don't set the collision category, it defaults to all. So it just collides with everything. So I'm going to delete that. Okay, so we're adding it. We've added the child node. I'm sure there's an add down here as well. So delete that. And then I'm going to get rid of all this extra material stuff. Okay. Anybody see anything else?
I think you still need to do the add because we need, so it's giving us a node right there in the delegate method, and we need to stick our node that we created into that node that's already been, so HICapacity adds the node for you at the place where the anchor is, and then we created a new node that we need to stick into that node that was given to us.
Is that what this one is doing on 122?
Oh, yeah, okay.
I think I saw the other.
Yep.
Okay, so we've added it. I'm probably going to pull it down though, just to kind of do all the initialization before I actually add it. I also see that I have this here, so I'm going to delete it. And I'm going to add the plain node to our root node right now, or the node that's been passed in through this method. That looks good to me. Build. Okay. And then the other delegate method was the did update. So I'm going to look for that did update in here. And I think we don't have to update it. I think it's just in there because we've already taken care of it. And it builds and succeeds. So I'm just going to run it on my phone and we'll go from there. Okay, build and run. And then, I don't know if you guys, I mean, I'll probably just upload this so you can try it on your own phones. Yeah, you can check it out later. But it's running on here. I'm just going to check for planes. All right, so just doing some detection. Okay, Leo, I'm seeing this is white, so it's really not getting any kind of feature points on it. I'm going to go over here. And I'm seeing feature points get, oh no, it's just some trash in the ground. It's an orange piece of trash. Okay, we're in, and I think we crashed now. Okay.
Looks like it was hit a breakpoint.
Oh, okay. So let's check out what breakpoints we have. Oh no.
Weird. Okay.
Let's see. Full screen this one.
Oh, I know what it is.
What's that?
I had an image in mine.
Oh yeah.
And you're not going to have it in yours, so it probably
the Tron albedo, right?
Yeah.
Okay. I'll go back to here.
Unexpectedly found no unwrapping an
Yeah. Where do you see that? Do you see it somewhere on the screen right now that I don't see? Oh, okay.
You try to unwrap something that's
Right. Okay. I know it. I know I have it. All right. So where is it? Okay. Contents right here.
So
and Shay, this is the little icon you were talking about, right? Right here.
Yeah. You can just put in a color for that. You can just do like
UI color
whatever.
blue or something.
Oh, I see. So it crashed because it was finding a non-existent essentially.
Image file.
Yeah, it happens.
Which that's a good sign though. It means that it found the plane.
Yeah.
It found the plane, but it crashed.
Okay. So this floor is actually really good for finding planes. So many feature points. Okay. All right. So crashed again, huh? Maybe we need to unwrap that. This is my code in here right here though. Plane geometry materials, material 0, diffuse, Tron albedo. Okay, so what it's doing here, I think, is it's adding, after Adam's already done the, created his plane node here.
Right.
Inside of there, it's already assigning the image. So I'm just going to remove this right here, and it should work. And we're just running out of time, so if you guys got to go, I understand too. I'm just going to just take care of this edit, and then should be good to go. So delete that, save, run one more time. So Leo, have you seen this stuff before on the screen yet, or?
No, I haven't.
Okay. Let me know if you want to see it later on.
Yeah, I definitely do. I think my next project, I want to mess around with that.
Yeah, it's so much fun. Oh, there we go. Okay, so I'm seeing a blue plane. Right, you guys really can't see that, but, and it looks like it's
It's growing, right?
Yeah, it is.
It's growing, right?
Yeah. Oh yeah.
It's growing.
Yeah.
Oh.
So now it's all the way over there now.
Cool.
So I can continue it. It's continuing and it's adding. So fantastic. All right.
Very cool.
Good job. All right. So that was ARKit Part 2. It sounds like Che wants to look into Unity. What is it? Toolkit.
There's a plugin for ARKit in Unity.
Nice. We're gonna cover that. Get Unity installed. So shut down the stream.
I got it installed. Problem is I forgot to. I have to register.
All right. So let's close down the stream.